Okay, let's look at cohort study. So a cohort study is when people are put into groups. So we see people in groups. Here's a group of smokers and here's a group of non-smokers, and we follow them over time to see who gets cancer. So people who smoked, 3 people got lung cancer. People who did not smoke, 1 person got lung cancer, and that could be because of maybe they were working in an area that was heavily polluted, for example. So the air that they were breathing caused them to have lung cancer, hypothetically speaking. Okay, so you have 2 groups of people, you follow them over time, and you see who gets cancer, for example. The key difference between a cohort group and a randomized control trial group is that here we randomly chose people to go into each group. But in a cohort, there was no randomization. I found the smokers, and the smokers are supposed to go in that group. I found non-smokers, and those non-smokers are supposed to go in that group. People were not randomly assigned to a certain group. A cohort study is also known as a prospective study because you're following them over time. You're going forward in time, you're following them. So after, let's say, 10 years, you follow them and you see that 3 people got lung cancer. After 10 years, you follow these non-smokers and you see that only 1 person got lung cancer. So prospective study means you're going forward in time. Something to remember is that with randomized controlled trial, this is what we really like to use. This is usually our gold standard when we want to, find a difference between, smoking versus non-smoking. We typically like to do studies in randomized control trial. However, think about what would happen if I use this as an example. Let's say I have a group of, people, a group of patients over here, and I randomly put them into groups, because that's what randomized control trial is. You randomly put them into groups, and let's say that this group, the treatment group over here, are given cigarettes, and the control group are continued to not smoke. They're continued, they're encouraged not to smoke. Is that ethical? Can I give my treatment group cigarettes and ask them to smoke and then I follow them up over 10 times? It's not ethical. It's not right. As a researcher, we can never harm any of our participants. And this is considered harming them. If I offer them cigarettes and tell them to start smoking, and then I'll I'll follow up on them in 10 years, to see how many get lung cancer, it's just not ethical. So that's why we sometimes have no choice but to use cohort studies where we find people that are smoking and we find people that are not smoking, and then we follow them over time. So randomized control trial, while it's the best type of study we like to use, sometimes, especially in situations like this, it's just not right. We can't expose people to cigarettes and give them lung cancer. That's just unethical. Okay, case control. So case control studies when you have a case and when you have a control. So this is your case, which is your cancer patients. That's your case. That's what you're interested in. So your group of interest, you're interested in looking at people who have cancer. And then you got to compare it to another group, which is known as your control or comparison group. And here you're comparing it to healthy people or just random people who have no cancer. What you're doing with a case control study is you're going backwards in time. So you have people here who have lung cancer, you're going back in time, and you notice that 3 people were smokers, and that's why they got lung cancer. Over here, you have people, just people from the street that you got to put into this group, and you go back in time and you see none of them have got lung cancer. And when you look at their medical history or health history, you find out that these people were smokers. That's why they got lung cancer. And these people here, when you look at their history, were healthy, were not smokers. And that's why none of them got cancer. Another example is, I'm just going to erase this. Another example is these people could have breast cancer. So you take history, you take their health history, and you find out that these 3 people over here, their moms or grandparents, grandmas, had breast cancer, and that's why they got breast cancer. So there was a genetic component. Whereas when you look over here and you go back, you'll see that none of them have breast cancer. And the reason, when you look at the history, is because none of them had a genetic component. Their mothers or grandparents, or grandmothers rather, did not have any breast cancer, and that's why they didn't develop breast cancer. So case control is known as a retrospective study, and the reason why it's a retrospective, retro means going back, is because you already have a group of people and now you're going back in time to see why they developed cancer. You have a group of people, you're going back in time to see whether, to see why they were healthy. So these people were healthy because they didn't have any genetic component. When you look at a cohort study, you're going forward in time, so it's prospective. When you look at a case control, you're going backwards in time, retrospective. Okay, then we have a case report, and a case report is basically when you look at one person and you do a case report, or you write a note on that one person. So let's say back in December, when this COVID-19 first came out, in December 2019, one doctor found someone who had symptoms of COVID-19 and wrote a paper on that. Then maybe later, another doctor found another person who got COVID-19 and wrote a paper on that. A case report is when you have one person who has symptoms and you write a paper on that. Case series, okay, so case series is when you now see multiple people getting COVID-19, and now there's a journal article written on these multiple people that got infected with the virus. So a case series is when you have multiple people, so all this is case series, and you write an article on that. A case report is just one person. One person got COVID-19 and a paper has been written on that. So case report is further down in the pyramid. It's not as good as a randomized control or cohort or case control study. Okay, so the best one is your meta-analysis systematic review. Then we have randomized control trial, cohort, case control, and case report. So we looked at all these. The next one is ideas, editorials, and opinions. So when you read someone's opinion on something, when you read an editorial, not as good. We like to see actual cases. We don't like to see someone's opinion on it. Not as strong, not as credible. Animal research, so sometimes when a new drug comes out, what they first do is they try it out on rats, and then they try it out on monkeys, and then they try it out on humans. So the reason why animal research is further down is because we need to see it on humans. We don't want to see it on animals. Yes, that's the process. Yes, we know we have to, do it on animals before we can proceed to humans. But in the real world, when we're looking at research, we want to see it done in humans. Okay, so that's why animal research is further down. And then lastly, we have the in vitro or test tube research, and that is any research done in the lab, not on animals, not on humans. So when we have research just done on labs, so for example, people will take extracted teeth, and they'll take extracted teeth, they'll put it in the lab, and then they might take the extracted teeth and dip it in Coke, for example, so in pop, and they'll see how long it takes for that extracted teeth to get decayed, or how long it would take for that extracted teeth to develop cavities. The problem with that is, although it's great, it's not in a human mouth. Ideally, in a human mouth, we have saliva, we have other protective factors, but in a lab, they don't implement those other protective factors. They don't put saliva there, right? So it's not as accurate. So that's why we don't really like in vitro test tube research.